Hello, everyone. Good morning or good afternoon, depending on where you're joining us from. Welcome to Biogas World's Germany Focus Month webinar discussing the challenges and opportunities of the biogas and biomethane market in Germany. As a reminder, this webinar is being recorded and will be shared with participants following the webinar. In addition, if you have any questions for our presenters, we invite you to write them in the Q&A tab, and we will ask our presenters following their presentations or in the Q&A at the end of the webinar. Biogas World hosts new country focus month webinars each month to discuss the opportunities and challenges within various markets. Be sure also to join us on our biogas community website for the latest updates and to network with companies in the biogas and biomethane industry. I would like to thank our presenters for joining us today. Michael Köttner, Senior Expert Trainer and Expert Witness at IBBK Biogas, and Tobias Reichel, Project Development and Sales at UIT. Our first presenter today is Michael Köttner. With a master's degree as an agricultural biologist and as a trained master farmer, Michael Köttner is professionally involved in biogas and bioenergy technologies for over 30 years. He is a founding member of the German Biogas Association, and since 2000, he is CEO and Senior Expert Consultant of the International Biogas and Bioenergy Center of Competence, IBBK, and Vice Chairman of the German Society for Sustainable Biogas and Bioenergy Utilization, GRBIO. The main focus of his work is expert consulting and training work in all aspects of biogas and bioenergy technology, as well as ecological sanitation in regional, national, and international context. So thank you, Michael. I'll pass the floor over to you.
Yeah, thank you very much, Ryan, and thank you to Biogas World to launch this meeting. Good afternoon from Germany. It's an autumny weather here in southern Germany, not quite sunny, but also quite mild. I want to talk about the German biogas market and the European a little bit. And I think what I have to do is to share the screen. And I will do. So can you see now? Can everybody see now? Great. Okay. I will talk a little bit first about the European and then the German biogas industry because it's all interlinked. All the major decisions are now made in Europe, in Brussels, and not so much in Berlin anymore. So I give an overview of the biogas plants in Europe and then specifically to the German biogas industry and then a small conclusion. First about IBBK, we were formed in the year 2000 out of some activities of an organic farming college and the founding of the German Biogas Association. And we work in biogas, but also not only in biogas, but sometimes also plant or wood gas, very interesting application now, biochar, and as well liquid and solid manure and digestate treatment, and also decentralized wastewater management. So the numbers of the biogas plants in Europe, and it's quite exciting what's happening now. We have almost 21,000 biogas and biomethane plants, and that's already over 21 billion cubic meters of total biomethane equivalent. And the goal of the European Commission in the Fit for 2055 is up until 2030 these 35 billion cubic meters of biomethane. So we are pretty much on track, it seems, with Germany producing more than half. This is an older chart here from 2019. This is somewhat reduced, but still Germany is produces over 50% of Europe's biogas and biomethane at the moment still. And that's quite interesting because only the second country is Italy, and then it's the UK. France catching up very fast as well, especially with biomethane. it's almost on the same level as Germany at this moment. The statistics they cannot catch up with the development, especially in France and some other countries. And we have 70 terawatt hours of electricity and 44 terawatt hours of gas production. And this also means that we have actually the equivalent of the total natural gas consumption of Poland or Belgium. So that's what we produce already. And what is also done is more and more we convert the biomethane into bio-LNG. LNG trucks are prevalent in United States and Canada. In Europe, they're still coming up, replacing diesel trucks, but this is happening quite fast. And also, we have the prospect of putting bio-LNG into the maritime sector, so in LNG ships as well, to decarbonize them. So what does the feedstock look like in Europe and in the main biogas producing countries, Germany, UK, and Italy? The feedstock mainly comes from agriculture. And then it's sewage sludge, and then it's landfill, and then it's industry. So agriculture means manure, liquid and solid manure. But it also means energy crops. And also it means agricultural residues like straw or like byproducts or like spoiled harvests and stuff like that. So that's where most of the energy comes from, not so much in the other European countries where there is still a lower uptake of biogas, and therefore we have sewage and landfill and industry with a much bigger share, but of course the overall production is much smaller. How does it look like with the energy and the number of plants? The energy you can see here is coming from agriculture mostly, is 72%. Almost 3/4 of the energy comes from agricultural resources, and in 65% of the plants, its agricultural substrates are used. So this is also due to the fact that we use in Germany, in Italy, in the UK, especially a lot of energy crops, a lot of high-yielding energy crops, and this is due to change. And let's see what's happening last. But first, let's look at what has happened in the past. In different European countries, we had support schemes. Without that, it wouldn't have happened because electricity and gas from biogas is not yet competitive with market prices of natural gas and normal electricity. So therefore, we introduced a feed-in tariff, and in Germany that meant for 20 years you get a fixed tariff. And of course, in the beginning, it's still good, but in the end, of course, you have higher costs, also inflation. So then it's not so suitable anymore, but also the plant is, of course, written off, so you still make good money. Also, feed-in premiums are paid. That means you have the base electricity or the base gas price, and then there's a top-up of a feed-in premium, which is then paid up to a certain threshold. Quota systems, they weren't very successful with electricity production, but they seem to be more successful with in the transport sector, especially in Germany. Even now we have a small problem that we have overfilled the quota, so to say, but this was due to a fraudulent influx of biodiesel from China. And it had an effect on the quota, and the quota price dropped. The price of CO2 dropped from 500 to 100. So this is 4 to 5 times less than was achieved before. So that is now on the way to being rectified, and we hope by next year the quota will increase again. Tax credit aren't very successful. They can just be additional, and tender systems also are not really really successful. Germany has overdone the tendering system, and it's actually the case now that the existing biogas plants cannot continue because there's not enough tender volume, and also the price for the tendering, the maximum price of the tendering is not enough. So that's a problem. In fact, we have 1,700 biogas plants at the moment which want to continue, and only about 550 were able to continue. So this is a problem that we will then, if nothing changes, have closing plants in Germany. Support schemes with biogas and biomethane were different as per country. I will not go into details. You can also see the different systems, and some countries have no support, and therefore yeah, but still, like Spain has no support, for instance, for biomethane, but still a very much emerging market for biomethane. And their business model is to sell directly or sell to other markets like Switzerland and Germany. Number of biogas and biomethane plants you can see here, and you can also see that the biogas production is more or less stagnating since 2016, but the most increase is in the capacity of biomethane. It's actually growing at a rate of almost 20% per year. So that's good news. And the countries where one has the most biomethane plants, it's Germany, it's Italy, United Kingdom and France, and Denmark and Netherlands. All the other countries, they're still catching up or trying to organize themselves. Here you can have an overview of where biomethane is produced in which country, and also the sizes of biomethane plants. And you can see that in Denmark and UK and Ireland, in Ireland there's only 1 or 2, they have very big biomethane plants with 1,000 to 2,000 cubic meters per hour on average. And in France, where they have the most biomethane plants, almost 700 now, there's only an average of 200 cubic meters per hour. So very, very small plants. They're not even catching up to Germany's 250 plants with an average of about 600 cubic meters per hour. So very small plants and medium-sized plants in Germany, and bigger plants in Denmark, UK, and in Ireland. Emerging markets are Spain, Poland even is producing biomethane, and the Baltic states as well, even they don't have their own support systems. But this is due to the possibility of trading within Europe's, and there's also going to be a big trading body coming up now, the so-called Union Database. A predecessor is at the moment ERGAR. That's a conjunction of different biogas registries. Those countries who already have registries, they are organized in ERGAR. This is Germany, Denmark, Netherlands, UK, Ireland, and Austria at the moment. All the other countries, they don't have registers, so therefore trade is difficult. So how is it going to go on in Germany? And the biogas plants in Germany are numerous, but not in every district, there are a lot of biogas plants. This is our district here, southern central Germany, and there are in our town there are 5 biogas plants. The smallest is 15 kilowatt, and the biggest is about 2.5 megawatt. So a lot of density of biogas plants in some areas and in others not. And the size ranges between 15 kilowatt and 20 megawatt. The development is remarkable. 30 years ago, we were building biogas plants from used parts on farms, small farm plants. Here, the first developments of a covered storage tank with a flexible membrane inside, not outside. It was supported by wooden struts. Here, we have, in 20 years later, not wooden struts anymore. We have air-supported outer membrane and inner membrane still flexible. And you can see also the catchment area of the gas became bigger for flexible production. So we produce electricity on demand. There's the curve of Germany with different there's not so much in the amount of biogas plant, but in the capacity of biogas plant. We will see later. Very complicated regulation. At first, when we started in 91, that's when I was just freshly coming to the Biogas Association and founding it. We had 5 paragraphs. Now we have many pages, I think 300 pages and 1,000 pages of comments. So it's become a thing of the lawyers, how to find your way through the jungle. Not to be recommended. But interesting developments are that with electricity production, the capacity of biogas plants stayed the same, the production stayed the same, and the capacity of the engine changed. They overcapacitated. That means a lot of biogas plants have, let's say, 24/7, 500 kilowatt, and they increased double or triple. That means they have a 500 kilowatt continual production in theory, but they have a 1.5 megawatt engine. That means they produce electricity only over 8 hours. So they catch the morning hours and the afternoon or evening hours when wind and solar is not producing. And that's when you make more money on top of your feed-in tariff. So that's interesting. And for those who have invested today, they are earning really good money. They have a future because the development of biogas plants in Germany is a bit dim. We have only 33 new plants, and also a few will be decommissioning. Still, we have a lot of jobs in the sector, 50,000. That means a lot of jobs in rural areas. We have still a lot of biomethane plants. That's without sewage, sludge, and landfill plants. That's why it's not 11,000, but only 9,500. That's what the counting of the German Biogas Association is all about. It's not including the sewage and the landfill. So it's an impressive industry, but we struggle because the shutdown of a lot of plants is looming, and those who haven't invested today in flexible production, in biomethane, it's difficult for them to continue, and we expect that basically if nothing changes and they go back to 24/7 production, many plants will shut down. Probably the scenario is not as bad as this one, but of the 11,000, we will have in the end perhaps 6 or 7,000. But what happens, it could be that bigger plants that they conclude together, and we hope this is happening. And also we hope and count on the innovation power of biogas in Germany. Change of feedstock is crucial. More excrements, less energy crops, less corn silage. We still have almost 1.4 million hectares in energy crop production, and mostly it's maize. So there is a maize cap for the future as well. And yeah, this needs to change. New plants only allowed to use 35% maize, and as from the 1st of January 2026, only 30%. So this is going to be the future, that we have low carbon feedstock, and carbon will be the future value of biogas and not the feed-in tariff. Small conclusion, biogas situation is changing due to new national legislation. Energy crops are becoming less economically feasible, replacement by sustainable feedstock, not only manure and residues, but also alternative feedstock which fixes nitrogen and CO2 in the soil is important in the future. So, but also we will focus on different ways of marketing the 80 products, biogas and digestate, flexible production of electricity, biomethane as a biofuel for transportation and direct heating, and also raw biogas, not only for electricity production, but for alternative use pathways. And of course, AD technology is always the solution for manure and biowaste treatment. Thank you very much for your attention.
Thank you for your presentation, Michael. I'll pull a question here before we continue from the Q&A. So someone is asking if there's a possibility that some of the German plants that are no longer viable for electricity production could instead switch to green hydrogen, under the assumption that they are aggregated or used as BTM applications.
Well, that's what's happening at the moment. Those who can switch over to green gas production, not only it's biomethane, of course. Biomethane, it's quite easy. You inject into the grid. Biohydrogen, yes, this is possible. At the moment, there's one plant which is doing the conversion of biogas to biohydrogen through steam reforming. Still, we have a lot of CO2 emissions through steam reforming. This is not the optimal case. We are working, IBBK is working with a international consortium on an Horizon Europe project on a possibility to produce biohydrogen and solid carbon. So we fix the carbon and not emit it into the atmosphere. So these are possibilities which are there to be explored in the future.
Great, thank you. And thanks again for your presentation. So we'll move on to our next presenter, Tobias Reichel. Tobias studied chemical engineering at HTW Dresden with main focus on biochemistry, bioprocess engineering, and biomaterials. He did his thesis on process development and scale-up and joined UIT at the beginning of 2024 to support in process development and sales. Tobias, I'll pass the floor over to you now.
Thank you, Ryan, for the introduction, and also thank you, Michael, for your insights. I felt like it matched kind of what I'm about to present. I hope you can all see my presentation, and yeah, like you said, I'm from UIT, or Umwelt- und Ingenieurtechnik in Dresden. We are also located in Germany, a little bit more to the eastern side. And our company has a long history with biogas, especially with biogas test plants. And so the talk I'm about to give is a little bit focused on the upcoming developments. As you know, there's always like the typical triad. You start with the testing, then it goes into pilot phase, and eventually it reaches the market. So we're kind of having a little forecast here, looking into the next years. And like I said, it kind of matches what Michael presented beforehand. Thank you for the notice. So yeah, what you're seeing here is start over here. What you're seeing here is our BTB2 series. BTB stands for Biogas Test Plant, and this is like our commercial product that we sell all over the world and sold all over the world. And it's used in a wide variety of applications to test different feedstocks, to test different processes, and see what the process would be like. It's scalable, so you get a lot of value out of testing within those reactors. Yeah, and the other hand, the other thing that we present is also like pilot scale. So we not only do the lab scale, but we also do the pilot scale. Yeah, and yeah, so we started just like IBBK in 2000. UIT existed a little bit beforehand that, but when in 2000 we started going into the biogas test plant market because there was a lot of demand there. And at first it was a lot of continuous stirred tank reactors. They were fairly simple to handle. They had to be utilizable for various substrates, and you had to be equipped with a good and solid parameter control and data logging. So yeah, those were the requirements in the first days of biogas testing, and it continued to be more complex from there on. Our BTB2 got to be the standard in biogas testing. It was applied in university and industrial research. There were a lot of projects done with those plants, and we still see them being used all over the world. And the trend that we're seeing here is that the tests that were done some years back in Germany, like in this period, they are now done in other countries where the development is not that far. So those plants are still relevant, but like a little bit more outside of Europe. The plant normally is equipped with standard equipment. You have like I said, a continuous stirred tank reactor. You have a pH sensor. You have a mixer unit. You have a gas meter, so you can basically log and control all the data that comes out. UIT has a control panel. It's equipped with the sensor control. That's the controlling software behind the whole system, which comes in handy for all of the relevant parameters and controlling them and logging them. Because we saw a lot of development when it comes to scaling the process of biogas production, we designed the plant so it would be easily scalable. And you see, we even go to the 1 cubic meter or 1,000 liter scale size. Yeah, this is also another overview about the different instruments attached to the plant. And you can see there's, after a certain time, we expanded on the basic concept of the plant, and we added the gas quality measurement, where you can log all the different gas parameters like methane, CO2, H2S, oxygen, and hydrogen. Some of the customers we had different requirements. They needed special feeding and discharge systems. So we attached a system equipped with eccentric screw pumps to feed in different and various substrates, realize different flow rates and particle sizes. All of those were tested in Germany. And we also see that this is now a thing that's happening in the market outside of Germany, where a lot of those tests are still run. So this is still a relevant system outside of Germany, especially. Yeah, in the following years, after the first period, like I said, we saw the demand for scalable reactor designs. We also saw the first methanizations and simple methanization tests being run. Also different and more complex substrates, and customers started demanding more customizable data parameters for the data logging system. So we went on and created a new standard, which is the BTB2 with the 400 liter reactor volume, to make more scalable tests within those, and have like a standardized reactor geometry for this size. A lot of customers stayed with us. They made their first tests with our plants, and then ran up to the larger volumes. And you can see a plant here that we designed, which had 5 reactors with a volume of 1,000 liters. And so we saw a lot of scale up being done from our initial systems up to plant-sized, technical scale plant size. Since a lot of our customers also needed the plants to be mobile, so you can do testing in the field, maybe where the feedstock comes from, maybe from different feedstock locations and sources, we equipped container-based plants with our systems. And you can see one here that's being transported around, tested for different feedstocks. Also a demand that we see a lot in Southern Europe, for example, in Spain, where those containers, some of those containers are located right now. We also had different and more complex requirements, for instance, dry fermentation, where it was tested to feed different dry feedstocks into the fermentation plant. It was then equipped with a conveyor screw system, so you can have the more demanding feedstock be fed into the reactor, and our standard gas equipment and gas quantity measurement systems. And this is actually in front of our construction site here. Yeah, and we continued to build different containerized plants. You can see one here where the feedstock afterwards is dried with a press, with a chamber filter press, and the whole plant is equipped with some laboratory equipment. This one was also built into a container. And now we come to the present day, to the demands that we see right now to biogas test plants. At the moment, we see a lot of very, very complex substrates being either dry or mixed substrates. We also see that the requirements for demethanizations grew. People are trying different methods, different biomethanization methods. And we also see that some of the processes now use pressurized vessels. We see a lot of hydrogen utilization, and different new operation modes for the reactors. For a lot of things that we see are fixed or fluidized bed reactors, so more complex reactor designs being tested in order to further optimize the biogas or biomethane production. I have some examples for those here. On the left-hand side, you see a biomethanization plant that we test plant that we built for the university in Rostock. So this is actually a development that's being done right now. It's 2 reactors being fed with different substrates. One of them is doing the biogas fermentation. One of them is doing the methanization. On the right hand, you see a image of the hyperferment project that's being done by the Fraunhofer IFF, which is a huge part of the research infrastructure in Germany. They're doing tests on the dark fermentation, or did tests on the dark fermentation in order to produce green hydrogen. They tried to optimize the fermentation within this plant, and they prepared for scale up. And right now they're actually in the second phase in Hyperferment 2. So they actually managed to successfully conduct their experiments and are now scaling it up to pilot or even technical size. So yeah, this project is actually already done and they're moving on to the next step. Another project that we done was at the Fachhochschule Münster, FH Münster. It's called HIMAT, and it was a project where they tried to utilize a substrate over 2 stages. So they first fed the substrate into a dark fermentation reactor, which is the smaller one you can see installed in the rack. And then the substrate after the dark fermentation stage was pumped into the biogas reactor to produce biogas from the leftover feedstock. And this also was done a little ways back, and it went on to being realized in a larger plant. And now some more recent or most recent one, we see the demand for photobioreactions, which is actually a little bit more complicated. So we designed or we're designing LED lighting strips for the lighting of the reactors. And we're currently realizing 4 different lighting types, 3 different wavelengths with infrared, red, and green lights, and also white lights at 2700 Kelvin. We also need those LED strips to be adjustable and steplessly adjustable. So we're realizing this. And the applications that we're seeing at the moment is algae reactions, algae reactors, some dark fermentation, and also some anaerobic digestion with purple bacteria. And another project that's also currently running is the pilot SPG at the DBFZ, the German Biomass Research Center. And they're actually testing a whole lot of variety of different substrates, some of them agricultural, some of them urban waste as feedstocks. It's a fairly complex design for a plant. They have a huge feedstock preparation, some hydrothermal processing of the feedstocks. Then they have the anaerobic digestion, then a catalytic methanization, and then the post-processing of various byproducts. And yeah, we realized this plant. So as you see, we did a lot of different biogas test plans. We are in contact with a lot of the research groups all over the world. And the takeaway message from this presentation, I guess, should be Germany has a few years ahead on most other biogas testing and biogas markets. And the trend that we're seeing here in Germany is that the applications, the requirements get more complex. And as Michael also said, we're seeing a lot of biomethane being produced, some green hydrogen being produced. And so we see that all of the processes get more complex. And I think this will continue into the rest of the world. And yeah, the German market keeps on growing as we see the demand for more biomethane. And so yeah, this is actually the trend at the moment. So thank you for listening to my presentation. If you have any questions, please feel free to ask. And you can find more information on our bioreactors and biogas test plans at our website. Thank you.
Thanks, Tobias. Before moving forward, I'll just pull a question from our chat here. So in your work with test plants, are you providing input on feedstock certification to establish the relevant carbon intensity scores?
We're actually producing the reactors, but we're working together with our customers. So the knowledge on what the feedstock needs to be most of the time comes from our customers. We try to be like guiding them a little and also take in their input on this. But yeah, we're not the experts in feedstock in this case.
Great, thank you. Thanks again for your presentation. So before we move to the Q&A portion of the webinar, I'll share some information about Biogas World as well as our recent showcase report featuring some notable German companies. So I'll just, if I could share my screen here. Here we are. So Biogas World is a commercial platform which offers services to the biogas and biomethane industries. Our services include marketing and business promotion via our wide network of followers, market intelligence services, networking, and our biogas community platform. We have hosted country-focused months for various national markets over the past year, promoting the industry, companies, and projects located in the focus month country. I'll quickly share two of our recent projects, our showcase report, and our biomethane projects map. First is our biomethane map, featuring an overview of biomethane projects in various countries. The map features the location of projects where available, some information about the type and quantity of feedstocks processed, the type of upgrading technology, the amount of biomethane produced, and the greenhouse gas emissions reductions as a result of utilizing the biomethane. The map is continually being updated and expanded upon to include more projects and include new markets. The map can be accessed for free from our biogas community website. The second is our annual showcase report, which features 45 successful biogas and biomethane projects and contact information for more than 30 industry leaders. The showcase report can be accessed for free or by following the QR code on this slide. I have a few examples to quickly share from the showcase report of successful projects completed by some German companies. The first company I'd like to showcase is Planning T Biogas, which highlighted some of the recent work of their US division. The success of the recent project in the state of South Dakota has set a new benchmark for the region, processing manure from over 15,000 dairy cows. The facility reduces fugitive emissions and provides fertilizers to farms in the local area. Bauer Compressors highlights the work of their North American division, particularly a dairy farm in Western Canada, where 500 normal cubic meters per hour of biomethane is injected into the local gas grid. The project notably features technology with optimal heat recovery, reducing the energy demand of the site. MRU Instruments highlights the work of their American division, supplying high-performance biogas analyzers to biogas facilities across the U.S., improving facility efficiency and optimizing biogas output. MRU analyzers integrate seamlessly with new or existing facility infrastructure. UGN highlights some of their recent work installing desulfurization equipment at 2 sites in Switzerland and Italy. The UGN team provides a range of services from consulting, process concept planning, to the construction, filter materials, and operation. UIT highlights some of their recent work for the Vila Real campus in Portugal. UIT supplied a modular biogas testing plant for continual monitoring and control of the system. The lab was fully customizable and featured control systems and data collection for each individual reactor. Finally, Evonik highlights some of their recent work in the United States, supplying the membranes for a number of upgrading projects. Evonik membranes have a high efficiency across a variety of feed inflows and no drop in performance over time, and have resistance to H2S of up to 3%. So thank you for your attention. I'll move to the Q&A portion of the webinar. And yeah, so I will open up some questions for our presenters. So first, maybe to Michael. So in the future, what are options for after the feed-in tariffs? So for the price of biomethane and what can influence that price?
Yeah, well, so the feed-in tariffs are only for electricity, not for biomethane. So the biomethane still goes into electricity production, but also heat production. Often biomethane plants are built in locations where there's no heat utilization possible, because we have a CHP unit, and CHP units have 40% electricity efficiency and 40% or 45% of heat. And often the heat is not completely used in rural areas, but in areas where there's a lot of heat use, you have biomethane CHP units, and there you can then also make money from electricity selling and heat selling as well. So that's the main thing. Still, 80% of our biomethane goes to that. About 15% of our other biomethane goes into road transport, and about 4% goes into heating buildings, and 1% about is to be traded internationally. So these are the possibilities, and there you can inject the biomethane into the grid, and those plants who don't have a possibility to continue with their electricity production and they're next to a gas network. In Germany, a lot of gas pipes are in the ground. Then you are able to connect to the gas network and produce biomethane.
Thanks. And one from the chat here. So is biogenic CO2 like a market you're seeing increase for these projects?
Yes, definitely, because we have a lot of demand of CO2 in the industry, especially in the food industry. And there's also in the future high demand on low carbon CO2. Most of our carbon at the moment comes from natural gas, is derived from natural gas. So it's fossil origin. And if we have non-fossil origin, of course, this has a big advantage in future decarbonization efforts of these food companies, for instance, and so on.
Thanks. And Tobias, if maybe the same question, is this something you're seeing for the biogas analyzers projects looking to utilize their potential CO2?
Yeah, definitely. So this is basically the trend that we're seeing right now with the methanization. The idea there behind this is that you need a source of green hydrogen, and in Germany we see a lot of different projects because hydrogen is and hydrogen production is hugely supported from the governmental side in Germany. So a lot of the research that's going on right now is focusing on using those upcoming sources of green hydrogen to increase the yield of methane from the biogas. So those 35% that you average have in biogas of CO2, they need to and want to utilize this as methane.
Great, thank you. Michael, you mentioned in your presentation that a lot of decisions are now made in Brussels and not Berlin. So are the main challenges between the biomethane industry connected for like Germany's challenges or general European challenges?
Yes, they are. For instance, a very big role plays the Renewable Energy Directive, Renewable Energy Directive 2, and especially now the new one since October 23, the Renewable Energy Directive 3, which is stipulating to use more sustainable fuels to reduce emissions in road transport, especially, and that's what Germany has translated. It has a mechanism of carbon trading in transport fuels, so it's a quota market in transport fuels, and that becomes interesting for biomethane production, especially from sustainable feedstock.
Great, thank you. And Tobias, so you mentioned there are many new feedstocks. Are there any examples of new feedstocks that you're seeing being tested?
What we see is mostly that people are trying to utilize urban wastes. So, for instance, if you have like wastes from the from restaurants, from different applications within the city, those are being utilized. So it's less about producing biomaterial and biofeedstock from crops, and more about using what's left over from society and from industry.
Great, thank you. And one more from the chat here. So, Michael, in your presentation, you mentioned there were only 33 plants added in Germany. So is there a particular reason why the number of new facilities is trending downward?
Yeah, the thing is that the heydays of the 20-year feed-in tariff is over. The high tariffs are now lower tariffs, and costs have increased. So therefore, almost no new plants are built anymore. There are, of course, some biomethane plants in the pipeline still, but these are not so many as we used to have. When we look back about 10 and 10 15 years ago, when we had a biogas plant construction of up to 1,500 per year between 2008 and 2011. So those days are over. We have a much lower feed-in tariff, and it becomes increasingly more difficult for new plants to be developed. So still we need to find new business models, and at the moment in Germany, it's actually we have to try and keep the existing ones operating. That's the main goal at the moment. Yeah.
Okay, thank you. And we start to approach the end of our hour here. So maybe before we conclude, I'll ask each of you a concluding statement on the market in Germany. So Michael, why don't we start with you?
Well, it's basically what I said before. We try to keep the existing biogas plants running. If we want to achieve the 35 billion cubic meters of biomethane by 2030, and if the German biogas plants are switching off, that's not a good sign. We will never reach this. All the other European countries, they can't catch up that fast to make up for the German losses. So we hope that impulses from EU and from German government will soon arrive, that this is not happening.
Okay, thanks, Michael. And Tobias?
Yeah, so my conclusion statement would probably be that we need to continue research, because there's still a lot of feedstocks left that are untouched yet, because people thought they would be unhandleable because of different challenges coming with those. But the last years have shown that those can be realized, and from those we can maybe reach our goals. And also the upcoming biomethane production also needs more research, more opportunities there. So keep up the research, keep up the work, and we'll reach the goal that Michael mentioned.
Great, thank you. So that concludes our time today. As a reminder, the webinar recording will be shared with participants next week. If we were unable to get to your questions, we'll share them with our presenters and invite them to send a response to the question via the biogas community. We invite everybody to join us on our biogas community platform to stay up to date and view content from our German Biogas Focus Month and to participate in October's Country Focus Month on the Nordic biogas market. I'd like to thank everyone for taking the time to join us today and thank our presenters again, Michael Köttner with IBBK Biogas and Tobias Reichel at UIT. Thanks, everybody.
Bye-bye.